motor A. Okay. So just to quickly, I know I don't have photographic memory. I want to bring this diagram here so you can still recap what we're trying to do. Okay, so we're going to focus everything on A. Why? Because we are given the acceleration at where? At A. Okay, we are given the acceleration at A. So we write our first, okay, so we have 0 omega A, right? So this is equal to omega E omega. Okay. Now we can no, this the first one, I do beg your pardon. The first one is not equal to 0. This is not equal to 0. I'll tell you why. If we go back to the question, what does it state? Starting at where? 3 radians per second. So it's not equal to 0. Okay. So now we know that this is equal to 3. Are we clear? Okay. So this will be equal. So we have a limit. Then we have alpha, theta, and alpha happen to be what? Given to us is 0.6 theta. Okay. D theta. Okay, so this over here is given. Now, if we were to go back to our question, they did state, okay, that theta is equal to what? Theta is equal to 0. Okay, right. So we know that theta is equal to 0 over here. Okay. However, what is theta A? Okay. We don't know what is theta A. Okay. So we have to now determine. Okay. So now we are going to temporarily stop. Okay. Okay. Why? Because don't have what? Okay. We don't have theta A. So now we have to find theta A. Okay. We have to now, what is theta A? Okay. What is theta A? So to get theta A, right, we now have to relate this. Okay, I'm going to copy this so I don't need to flip around. Okay, so theta A is related to S, which is equal to 0.5. Is it in inches or in meter? Wait, I could not remember. Which is related to S is equal to 0.5 meter. Why is that? Okay, so if we were to go into our pulley system, if we were to draw this, you don't need to do this, okay? I'm doing it because I need to sketch this out. I need to write something. You can edit you can add this in your figure. So we know that this block S have to go up by 0.5 meter. So if we have an initial position of our block, it has to rotate by what? It has to be rotated by theta C. And this theta C is going to give us an arc length like this. which I will call this SC. And because the pulley will not slip, okay, assumption that we make, over here on motor A, it has to rotate by a certain distance. I'll draw a bigger distance. And this distance is equal to SA. Okay. So we did find a relationship from the block to the arc length of pulley C to pulley A. Yes or no? Assuming that there is what? Zero slip. Okay. I understand that this is a bit draggy. Okay. But because there's a lot of layers, some of you can see it straight out. Some of you don't. Okay. I'm not leaving anyone behind. Okay. I'm going to take my time on this. Not like last week. Last week I was sleeping. So we can see over here. So the formula first, let's write out for the formula for arc length. Which is equal to C, which multiply by R theta. Again, theta has to be in what? Radians. Any idea why we have radians and degrees? Why two system? Anyone? Or you just accept the fact that we just have radians and stuck with it? No. Okay, it's important for you to know. If I say 3.141592654, what comes to your mind? Yeah, we are engineers, we pi. But if you say this to an art student, what do they have in mind? You're crazy. If I say 180 degrees to an engineer, what do you have in mind? Half a rotation. If I tell an art student, 180 student, what do they have in mind? Half a rotation. Are we clear? It's a frame of reference and it's just a language. But whenever you do any programming, how many of you do programming in Fortran or MATLAB lab? You have to use what? Radians. If you use degree, answers all will be wrong. Are we clear? Okay, so when you do any programming, it all has to be what? In radians. When I say software programming, how many of you hate software programming? Don't. Okay, it's good. Okay. Right. So we know there's an arc length now. Okay, arc length. So now we know for the fact, okay, that SC is equal to what? SA. Okay. So now we have to find what is SC. We can relate to SA. Then from here, we can, then later on, we can get SA is equal to RA what? Theta A. We need this badly. Are we clear? Okay. So that is the relationship. Okay. Right. So we are going to compute what is our SC equal to. Okay. So for now we know SC is equal to theta D RD. Okay. Okay, we know that is equal to theta D RD. Sorry, SC is not equal to, wait, let me, I need to look at my diagram. S is equal to 0.4 theta D RD. Then, yep, okay, so SC, right? Sorry, it's not SC. First, I have to compute what is our, yeah, S, no, it's not SC, S. Okay. Is equal to theta D RD. So S is this distance that I want to focus on first. Okay. So we have 0.5. This will be equal to theta D, right? And then relate to what? RD. So our RD magnitude is equal to 0.075. So from here, theta D is equal to 0.075 or 0.5 divided by 0.075. You get 6.667 radians. And this is also equal to theta c because of what? Because of rigid body. Okay. Then from here, we can relate SC is equal to SA. Okay. So SC is equal to 6.667 multiplied by radius of C. So radius of C, if we were to just quickly look, is 0.15. And this will be equal to SA. So SA will be theta A multiplied by a radius of what? 0.05. So from here, theta A will be equal to 6.667 times by 0.15 divided by 0.05 will be equal to 20 radians. Okay. So coming back to our equation, right? So we have what? We have 3 omega A. We got omega d omega. And then we're going to integrate within the boundaries of 0, 20, 0.6 theta, d theta. Okay. So this is really straightforward now, I hope. So this is equal to, by the way, I can tell you one thing for sure, your math is better than mine, okay? You've been through more math than me, okay? So omega 2 over 2, this is omega A, this is 3, and then this will be equal to what? 0.3 theta squared. And then this is 0, and this is 20. So what we have over here is omega A squared over 2 minus by 9 over 2. And this will be equal to 20 squared times by 0.3, 120. Okay. And then we are almost done, okay? You guys are thinking this is an endless journey, you know? So from here, we get omega A will be equal to 120 plus by 9 over 2, okay? Minus plus and multiply by 2. And the whole thing, we are going to square root it. So omega A is equal to 15.78 radians per second. Any questions so far? All good? I'm looking for a student. The name is Itop. The family name is Itopgi. Are you here? No? Itopgi. No. It's okay. Just to clarify, he did nothing serious. His dad is my PhD student. Yeah, so I'm just looking for him. Probably he's here, but he's quiet. Not going to own up. Okay, but it's okay. Any of you know Itopgi by the last name? No, I'm just kidding. I'm just kidding. Okay. That's what we call spirit of perseverance. Right. So from here, with this graph, we know that VA is equal to what? It's equal to VC. Okay, we know VA is equal to VC, right? That's what we want to relate. We need to know what is VC. So after we know what is VC, we can find theta C. Then from theta C, we can relate to what? velocity of the block. You can see the amount of layers, right? I've done a lot of questions like here and 3A. This is one question that the amount of layers is a lot. Okay, it's not difficult. It's just a lot of stages. Okay,